Welcome to BitSpace Education. So you see
You.
the BitSpace Education poster here. So this is a coding, computer science, and math school. So we offer various courses in coding and also in the math programs. So we have started this school. This is me, Akila. My name is Akila. I have been teaching in the education industry for the past 13 years. I have taught in India initially, and after moving to Canada, Vancouver, I am still teaching. I teach at BCIT, and I also teach coding to high school students after school programs. So my expertise is teaching students for the Canadian computing contests, both junior and the senior level, and also the AP computer science courses. So for the past 5 years that I have trained the AP students, more than 90% of the students have got a perfect score of 5. And even in the Canadian computing contests at the junior level, many students have scored, nearly 80 to 90% of the students have scored more than 70 out of 75. And at the senior level, they have scored good scores as well. So that is what I basically teach. And I also train younger kids in Scratch programming language, in Python, and even we do basic courses in Java for younger students. So any student from grade 4 to 12 can join our school to learn the coding and the math programs. So today, what I'm going to do is I'm going to show you how to work with loops. And also we are going to work on a problem. I've selected a problem from one of the previous years of AP questions. So we will try and solve that problem today.
Can I have a question? Is this today's question are from AP exam?
Yeah, it is one of the questions from the previous years.
But I'm just curious, like, why do I need to study AP computer science?
Oh, that's awesome. That's a very nice
my
question.
goal is to get a computation.
That's a very nice question. So AP Computer Science is basically the university's first semester curriculum. If you get a 5 grade in that, most of the universities, they consider your application to be a stronger one because you have challenged the university's curriculum when you're at school, and you also get to skip. You have already gotten the required credits for that course when you're at high school. So you can skip the university's first semester curriculum if you choose computer science as your major in the university.
I see.
So now this is the platform that I'm going to use to type Java programs. This is IntelliJ, which is from the JetBrains company. So we have 2 editions in this, Community and Ultimate. Community edition is free. So I have downloaded the Community edition, and I always use this is like an IDE, Integrated Development Environment, where we can type the code, we can compile, execute, it's all in one. So I will show you as we type the code, we will see how to work with that. So in today's class, we are going to talk about loops. So I have created a class. This is the main method that we use to execute any Java program. Now, could you please tell me what is a loop in English? What do you know about a loop?
I know nothing about loops.
Forget about coding, forget about computer science. In English, what does loop mean?
Loop means
Okay. Now, that's okay. No worries. I will tell you what a loop is. A loop is something which repeats over and over, right? So there may be some processes. Say if you go to a manufacturing industry, there may be some process which goes into a loop over and over. It keeps running over and over until it meets meets an end, right?
Mm.
So in coding also, a loop is something similar. If I tell you to print 100 numbers, or say, let's take a smaller number. If I tell you to print 10 numbers, the first 10 numbers, what is the code that we will write? I may write system.out.println 1, system.out.println 2, print line 3, and so on. I will write 10 statements like this to print 10 numbers.
Mm.
Or what I can do is I can also write it in a single statement, but I have to write it as a string. I can write print 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I can do this, but this may be possible because the number is smaller. I told you to print only 10 numbers. Do you think either of these ways is feasible if I tell you to print 1,000,000 numbers? System.out.println is the print function in Java, which is used to print something onto the monitor, onto the output stream. So this println stands for line. Println is the function. It is the method that is used to print something onto the output stream. So system is a class, out is an attribute, system.out.println. In this class, we have the println function, which is used to print something onto the output stream. I'm executing this now. You'll be able to see what it prints on the screen. So you see that it is getting executed here. It says parsing Java. Now this is the output part. So it has printed all the 10 numbers, 1 to 10, because that's what I have written here. This is a string that I have written within double quotes. So it has printed the numbers from 1 to 10. Is it possible for you to write the code if I say that you need to print 1,000,000 numbers? Can we start writing 11, 12, 13, and so on? Can we write up to 1,000,000?
No,
No.
too much work.
We may write. It will take a longer time. And
Mm.
moreover, it is not a very efficient way of coding, right?
Yeah.
So if you have to achieve that, see, now you see that the process is repeating here. We are trying to print numbers over and over until a certain limit. The limit here for us is 10, right? Now the process of printing the numbers repeats. So for this, we are going to use a loop. There are two types of loops in Java. I'm going to write it in the comment part. This is the multi-line comment. In Java, you can use /* and // for multi-line comment. Whatever you write within this is a non-executable code. You can write whatever you want in English, plain English, however you want to understand, you can write it. We also have single line comments. Single line comments are // I can write, this is the print function in Java. So anything written in // or this multi-line comment, they are non-executable statements. So there are actually 3 types of loops: while, for, and do while. These are the 3 types of loops in Java. First, let us see how to work with while loop to achieve the same thing. In that case, you can print any number of values. So my initial value is 1, right? I'm writing a while loop. So my initial value is 1. Now I need to write, while is the keyword. I need to set the condition. What is the condition? I less than or equal to 10, because I want to go up to 10. I less than or equal to 10. I'm going to print I. We can also use the print function. The difference between print and println is that println prints the string, whatever, or prints the output and then comes to the next line. But print stays in the same line.
Teacher, I have a question.
Mm.
Why we have the grey words there? The grey words. What is that?
One,
Yeah.
this is a comment. They are
Oh,
not executable statements.
why
So
do we
actually-
have this?
Sorry?
Why do we need to put
Oh, why
this?
do we need to write comment? Comments are very useful for programmers because today, if I work in a software industry, I may write code. I may work in the software company for 5 years, 6 years.
Mm.
I may quit and move to a different place. So if
Mm.
someone takes my place, they should be able to understand what I have done so far, why I have written this piece of code, what is it doing. So if I go to this system class, see, this is a Java doc, which tells about what this method does, right?
Mm.
There are so many Java doc comments. See, this is a comment. This is a built-in class in Java. It says indicates if a security manager is possible. So it gives meaning to what we are writing. So it is understandable by others. Even if some third person looks at your code, they should be able to understand what you're trying to achieve in that code.
I see.
So here I'm trying to print the numbers from 1 to 10. So we need to increment the value of I every time. So what this does is, now it is again executing the code. It does the same thing. If you see, the first line of output is from this line number 3. The second line of output is from the loop. Because I said the initial value is 1 and I set the value to less than or equal to 10. First time I takes the value 1, it checks for the condition if it is less than or equal to 10. Yes, it is true. So it comes inside the loop. It executes this line, which is i's value. I's value is 1. So it prints 1. And then it increments the value of I to 2. Next time again, it goes back to the loop header. It checks if 2 is less than or equal to 10. Yes, the condition is true. Again, it prints this 2 and a space. Now I gets incremented to 3 and it goes on. When I becomes 10, it comes inside the loop because 10 is less than or equal to 10, which is correct. So it prints 10. Excuse me. And then it goes to 11. When it goes back to the loop header, 11 is not less than or equal to 10. Now it should stop executing the loop statements. It should come out of the loop block. This is the loop block. So we have to put the curly braces or flower braces for the loop block. Whatever statements are written inside this block will get executed over and over until this condition becomes false. There should be some statement inside the loop which makes this condition false. Do you know what will happen otherwise? If this condition never becomes false, what will happen?
Don't know.
Okay. It will become an infinite loop. Say, for example, I don't have this I++. So what will happen? I is set to 1. It will check 1 is less than or equal to 10. It will print 1. Goes back again. 1 is less than or equal to 10. Yes, it will print. Goes back. 1 is less than or equal to 10. It will keep printing 1 infinitely. There is no end to it. Right? So we need to have some statement inside the loop which stops the loop from executing it infinitely. So this is that statement. Because we keep incrementing the value of I, it keeps incrementing every time. And then at one point of time, it will reach 10 or it will reach 11, which is greater than or equal, which is greater than 10. So it will stop executing the loop.
Oh, so when the number is ended at 10, it will stop.
Yes, that is correct. Not 10, 11. It will go up to 10 because we have written less than or equal to 10.
Okay.
Yes. When I becomes 11, it will stop executing the loop.
Oh.
Now the same thing. I'm going to comment all of this part.
How do you do that?
Oh, okay. So if you want to comment out everything, now it was like this. What you need to do is you need to select. I'm using a Mac, so I'm using command slash. If you use Windows, you have to use control slash to comment out all the statements.
Slash. It's good to know.
So now let's write a for loop for the same problem. Let us see how a for loop works. So for is the keyword, followed by for has three parts in it. The first part is the initialization part for I equals 1, I less than or equal to 10, I plus plus. So here if you observe in the while loop, we just have the condition. Initialization is done outside the while loop and the increment part is done inside the loop block. But here in a for loop, we put all three in the same loop header. So this is the initial value of the loop variable I, which is of type integer. And then this is the loop condition. What should happen to this loop variable after each iteration? What is an iteration? When the loop body executes once, it is one iteration. When the condition is true, when it executes the loop body, it is called one iteration. Next time it checks the condition, executes again, it is second iteration, and so on. So what should happen to the loop variable after each iteration that I have given here? This is the condition. This is the increment, I plus plus. So I's value should be incremented by 1 every time. So here I would simply write print I. So what happens? What happens is, say, for example, we have I as a variable. I initially takes the value 1. When I takes the value 1, it checks if I is less than or equal to 10. Yes, correct. It comes inside, it prints 1. So this is the printing part. This prints 1 and a space. Now this gets executed, I plus plus. So I becomes 2. When I becomes 2, the condition should be checked again. I is less than or equal to 10. Yes, it is correct. So it comes inside the loop and prints 2 and a space. Now I's value should be incremented to 3 because this is I plus plus. I will be incremented to 3. And now again we check the condition less than or equal to 10. Yes, it prints 3. Now I takes the value 4 and so on. It goes up to 10. When I takes the value 10, 10 is less than or equal to 10. So it prints all the values up to 9 and then it also prints 10. After that I plus plus, I takes the value 11. When I takes the value 11, what happens? It checks if 11 is less than or equal to 10. No, the condition is false. So it comes out of the for loop. It will print only from 1 to 10. Now tell me, would you be able to print million numbers?
No, maybe because it less than 10, it will.
Correct. We cannot print using the same loop. But if we modify the condition here, would we be able to print million numbers?
Yes.
Yes, for sure. We don't have to write million statements to print million values. All we need to do is just write one statement and change the value here. Instead of 10, we are going to make it million.
Oh.
Do you understand the power of loops?
Yeah.
Yeah. Yeah. So this is the basic idea of while and for loop. We will discuss do while loop in some other class. I want to switch to solving a problem, AP problem based on loops. Okay. So we'll do that now.
Also, I have a question. How do I know when the loop ends?
When the condition becomes false, I wrote and showed you here, right? Wait, let me see if I can go back. Undo. Yeah, I wrote the I values here. If you see, first I is initialized to 1. So I put 1 here.
Oh, so you have to
For
put one in the coding? Which
this
one?
is how the execution will happen.
Ah,
Wait, I will show you otherwise. There is one more thing, which is I will visually show you how it works. There is a Java visualizer. What I need to do is, I'm just copying the code that I wrote now. I'm using a Java visualizer, which is from the University of Waterloo.
mm,
This is a very useful tool to understand the flow of execution of our code.
mm,
So this is the loop that I have written. Say I name the class as main. So this is the main method and this is the loop I just wrote and I've just copy pasted it from there. So visualize execution. When we say visualize execution, see what happens. Always in Java, the coding, the statements will start executing from the first line of the main method. So main method is mandatory. If you see, this line is getting executed here. You see a frame here, main, it says main line number 3, which is the first line of the main method. So let us see what happens when I move forward. You see variable I is created in the main frame, which is of type integer. So I takes the value 1 because
what
that
do
is
you mean frame and method? I don't know this word.
frame is nothing but it is a stack frame. So when we write methods in Java, each method will have its own frame because we have something called as local variables. We have something called as static variables. I will discuss all about that later. But for now, just understand that every Java program will have frames, which are for the methods that we have in the class. Now we have only the main method, so we will see only the main frame. When you have more methods added up, then we will have more frames. It is just for Java to understand how to navigate from one method to the other, how the control will get transferred back to the method from where it is being invoked. I will tell you all that when we discuss more about methods. That's a good question though. So I takes the value 1 here because that's what we have initialized. When I say forward, it checks for the condition I less than or equal to 10. See, it prints 1. You see the output here?
Yeah.
It prints 1 because the condition is true. Now next time I takes the value 2. That is because I have written I plus plus here. Plus plus is an increment operator which increments the value of I by 1. So now i's value is incremented to 2. Checks the condition 2 less than or equal to 10. Yes, it is true. So prints 2. So I move forward. Now I takes the value 3. The 3 is less than or equal to 10. So it prints 3. You see the output 3 here. Again, we just move forward every time. It keeps incrementing. You have to observe here on the right hand side. It keeps changing the values every time. Now let us see. I is 10. So it prints 10. Now what happens? I becomes 11. Now when I becomes 11, this condition fails. I less than or equal to 10 fails. So it did not execute the statement. It comes out of the loop block.
Okay.
That is all. Now the program execution is done. Yeah. So this is how we write loops in Java.
Good.
Now let's read the question. Now, so, we just discussed about loops. So like I mentioned before, let's solve a problem based on loops. So this is, if you see here, I have picked the question from 2018 AP Computer Science free response. This is one of why I chose this question is because it's really interesting. Of course, all questions are interesting. This is one of my favorites.
Yeah.
So this question, the challenge in solving an AP free response question is the questions are long. So you need to read and understand the question first. And you don't have to write the entire class. The class information is given in the question. All you need to do is write two methods. So if you observe here, it says to be implemented in part A, and this says to be implemented in part B. So this is all you need to write, a piece of code. So it is not super hard, but then you need to read the question and understand, and you need to solve it in 20 minutes. So that is the time you have to solve one question. So here we have the class frog simulation. And if you see in the question, we have two attributes. One is the goal distance and the other one is the max hops. These two are the attributes of the class. And here we have the constructor for the class. So frog simulation, int dist and int num hops. We are passing two parameters to the constructor. So this goal distance is assigned the value of dist, and max hops is assigned the value of num hops. So the constructor, in the constructor, we are trying to initialize the values for the attributes. So it clearly says here what the constructor is doing. It says, and also if you see here, comment is written. One of your questions where, when I was teaching loops, one of your questions was, why do we write comments? So to understand what goal distance is and to understand what max hops is. So this says distance in inches from the starting point to the goal, maximum number of hops allowed to reach the goal. And then this is a constructor which constructs the frog simulation. Here dist is the distance in inches from the starting position to the goal. And num hops, this is the maximum number of hops allowed to reach the goal. Distance will always be greater than 0. Num hops will also be greater than 0. That is the precondition. Now we have a method called a hop distance, but the implementation is not shown. You don't have to worry about the implementation. We have to assume that this method works fine. When invoked, this method will work fine. What will this method do? What is the work of this hop distance method? It will return an integer representing the distance in inches to be moved when the frog hops. So it will return some integer value. It could be a positive integer or a negative integer, but it will return some integer value when this method is invoked. And then the next is the simulate method. Simulates a frog attempting to reach the goal as described in part A. And it should return true. If you see here, the return type is Boolean. If it is Boolean, it can return only two values, either true or false. So it simulates a frog attempting to reach the goal, returns true if the frog successfully reached or passed the goal during the simulation. It should return false otherwise. Run simulations is another method that we need to write, which should be implemented in part B.
Where does this question come from?
This question, I will give you the link. If you go to, let's say I'm opening up. It is from the College Board. So you can just type AP Computer Science A pre-response questions. You see the College Board link?
Yeah.
So this is, you will have all the previous year's questions in this link. So this is specifically for 2023 because I clicked the 2023 one. Past exam questions. This is the link. So AP Computer Science A, past exam questions. If you scroll down, you will see all the previous year's questions. If you expand, you will see question number 1, 2, 3. Free response questions. If you click on this is the PDF which has all the 4 questions.
Okay. The loop we learned today, I can practice here.
Yeah, for sure. Yeah, that's why I chose this problem.
I see.
So, yeah. So now, yeah, run simulations, we were here. This run simulations method we need to implement in part B, which runs simulations and returns the proportion of simulations in which the frog successfully reached or passed the goal. So what you need to understand from this question is that, see, imagine there is a line, right? Imagine there is a line. The frog is here. Say the frog is standing here. This is the frog. It is at the starting position. Now, if I say the goal for frog is to reach 24. If this is the goal distance, it starts at 0, which is the starting point. It has to reach a goal distance of 24. And how many hops I am giving the frog? I am giving 5 hops. Now, our part in the simulate method is to check whether the frog can hop in 5 hops or not to reach the goal distance. Right. Now let's move a little forward and read the question a little more. So what we have here is write the simulate method, which simulates the frog. Sorry. It simulates the frog attempting to hop in a straight line from the starting position of 0. That is why I put 0 here. If you see, this is the starting position. Within a maximum number of hops. Maximum number of hops is 5 in my example. The method returns true if the frog successfully reached the goal within the maximum number of hops. Otherwise, the method returns false. From 0, if the frog is able to reach the final position of 24 in 5 hops, then you have to return true. If it cannot reach the goal distance in 5 hops, then we have to return false. Now we have the method called hop distance in the class, in the frog simulation class, which will return a random value, random integer value. Every time you call this method, it is going to return a positive or negative integer. When the frog hops, it is going to give you a value. Positive distance, if it returns a positive value, it is we are going to move the frog forward to the goal distance. If it is a negative value, we are going to move it back. It is moving away from the goal. So the returned distance may vary from call to call. Every time you call this hop distance, the value that it returns is going to be different. Each time the frog hops, its position is adjusted by the value returned by a call to the hop distance method. These are the conditions. The frog hops until one of the following conditions becomes true. When will you return true? The frog has reached or passed the goal. The frog has reached a negative position. You will not return true, but you will return false in that case. The frog has taken the maximum number of hops without reaching the goal. Even then it is false. When will the frog stop hopping? One of these 3 conditions. Either it has passed or reached the goal, or it went to a negative position, or it has taken the maximum number of hops, which is 5, but it could not reach the goal distance. In one of these 3 conditions, you have to return either a true or false. So this is the example. In this example, it shows a frog simulation object. Goal distance is 24. That is why I put 24 here. Maximum number of hops is 5. So we have 5 hops. First time, what happens? I call the hop distance method. That method returns 5. When it returns 5, what does it mean? It is a positive 5. So the frog is at 0. which means the frog now hopped 5 units, and it is in fifth inch now. From 0, it hopped to 5. Now, next it returned 7. So it has moved 7, and now it is at 12, because after 5, now the frog is here. When the frog is here, it is hopping 7 inches. So from 5 plus 7, it has hopped to 12. Negative 2. Negative 2, now the frog hopped back 2 inches, which is at 10 now. Next time, it hops 8 units. 8 units is forward. From 10, it is hopping 8 units, which is, say, 18. Now it is at 18. Now, in the last hop, it hops 6 units. From 18, 18 plus 6 is 24. Now the goal distance is 24. Did the frog reach the goal distance or not?
Yes.
Yes, obviously, because it reached the end. So what value should we return? True. Did you understand this output?
Yeah.
So if you have to keep adding all these values to see if the frog has reached the goal distance or not. In the second example, first time it hops 6 units. So from 0 to 6. Second time it hops 7 units. So 6 plus 7, 13. Third time it hops another 6. 13 plus 6 is 19. Fourth time it hops 6. 19 plus 6 is 25. It has crossed the goal distance. Now 25 is after 24. So it is here. Now the frog is here. It has crossed the goal distance. So in 4 tries, the frog has just hopped 4 times. But in 4 hops, it has already reached the goal distance. So it does not have to hop again. So the 5th hop is not required.
Oh.
Because the frog has already reached the goal distance, which is 25. Now again, you have to return true.
Oh, but
You,
the range is from 5 to 24, right?
not 5 to 24, 5 hops. This is the number of hops. 24 is the goal distance. It has to reach 24. Whether it reaches or passes 24, we have to check that.
Oh, then we have 25 now.
Yes, we have 25, which is greater than 24, which means it crossed the goal distance, which is
why it is still true? It should be false, right?
Why would it be false? Because it has crossed the goal distance.
Oh.
It has to go only till 24, but it has gone even more, even greater than 24.
Oh, I see. Okay.
So similarly, we have other examples for you to understand. You can check out these examples. We worked on 2 examples. Similarly, there are other examples. Now let's try to write the code for this. So you have to remember what you're expected to do in this. We need to call the hop distance method to get these values. We have to cumulatively keep adding them. Simultaneously, we have to check if we have reached the goal distance or not. So I have written the class here. I have kept it ready for us to write the code. In the actual exam, you may not be writing all this. Just for you to understand, I have written all this here. In the actual exam, you will only write these 2 methods, simulate and run simulations method. Okay, so let's try to write the simulate method. First, what is the starting position of the frog? Where does this frog start from?
0.
0, very good. So the frog starts at 0. So I have set the initial position to be 0. Now, how do we know how many times the frog can hop? Is there any variable or attribute that you can find from these two, which tells us how many times the frog can hop? It is given by the attribute max hops. Max hops is the attribute which tells us how many times the frog can hop. In the example that we considered, it is 5 times. It is not always 5 times. It can be any value. That is just an example to understand what we have to do in the problem. Now, you have to make the frog hop once, hop twice, hop thrice, 4th time, 5th time. So there is something repeating here. So what should we do for that? When something is repeating over and over, what do? We write a loop, right?
Yeah, loop.
Yeah, that is what we discussed. So let's write a for loop. Or I want to start with the first count to be 0 and up to count less than max hops, count plus plus. So first time, how do we know how much the frog has hopped? We have to call the hop distance method. If you call this hop distance method, it will return an integer value. So from 0, you will add that returned value to get the new position of the frog. So position plus equals hop distance. Whatever value this method returns, that will be added to the position value. So if this position is greater than or equal to goal distance, then what we should do, we have to return true. We have to keep adding the position like how we did now in the first example. First it hops 5 units, then it hops 7 units, then it hops -2, then 6, then 8, and so on. So at any given point of time, when you keep adding it, why we are checking the if condition inside the loop is because we don't want to execute the loop unnecessarily up to the max hops, because the frog may not need 5 hops to reach the goal distance. It may reach, in the second example, we saw that the frog reached the goal distance even before the maximum hops were reached. It just needed 4 hops. So in order to avoid executing the loop over and over many a times, which is not required, every time after we accumulate the position value, we check. If the position is greater than the goal distance, then immediately return true. Return is the end of the method. When you return a value, it is like it will not execute any other statement after the method. After the return in the method. Else if position is less than 0, then you have to return false. Anytime the position goes below 0, which is negative, then you have to return false. Outside the loop, we are going to return false. That is for the third condition. The number of hops are done. Now we have given 5 hops as the maximum hops. The frog has completed all the 5 hops, but it still is not able to reach the goal distance. So in that case, you have to return a false. So we have covered all the 3 conditions. If you see, the first condition is the frog has reached or passed the goal. That is what we have checked here. If the frog has reached or passed the goal, that is this if condition. The frog has reached a negative position. If the position, what is negative? How will we find if a number is positive or negative? If a number is less than 0, then it is negative number. So if the position is less than 0, then you have to return false. So the second condition is covered. Now the third condition, the frog has taken the maximum number of hops without reaching the goal, which means the loop has executed completely for the maximum number of hops, but the frog was still unable to reach the goal distance. which is why we are returning false outside the loop. So you have to check whether we have implemented all these three conditions. Yes, we have implemented all the conditions. So this is the simulate method.